The last section of the chapter, which means I'm going to give you today and tomorrow to work on 3.6. We'll be reviewing on Wednesday and a chapter test on Thursday. No school on Friday. I know. It's not my choice. I mean, it would be, but yes. Okay. You'll just have to make it up when you get back. Okay, so this, we're just adding a variable in. So now we have 3 equations, 3 unknowns. Okay? We did 2 equations, 2 unknowns. Now we're doing 3 equations, 3 unknowns. I think in the textbook, they went through a few examples of if I were to graph 3 equations, 3 unknowns. There's a possibility that one solution exists, no solution in that they cross each other at 3 different places, or infinite solutions if the answer is a line where they cross, it happens to be a line. Okay, WebWork does a pretty good job of throwing in no solutions and infinite solutions. So when you look at your equations in WebWork, if you can tell that one equation is just a factor of the other, you know they're the same line, right? Or if one equation is a factor of the other, all except for the constant, then they're going to have no solution. You know what I'm saying? Same kind of rules we did with 2 equations, 2 unknowns apply for 3 equations, 3 unknowns. Some of them will have one unique solution. What I want to do in class is go through an example of how you solve these. The video, if you watch that, does a really good job of showing you how to solve. But I want to do an example as well. As soon as my starboard comes up. Good to know. I want to do it in blue. X minus 3y. Okay, 3 equations, 3 unknowns. X, y, and z are what we're solving for.
Correct.
Okay. In these problems, unless it gives you, x equals something, or y equals something, or z equals something, I would use elimination. Okay? Because when you start using substitution for a problem like this, I would have to look for, maybe solve for y or solve for x, and I can see right away I'm going to deal with fractions. And putting a whole fractional equation in for a variable when I've got 3 variables, it will definitely end up with you making an error. Okay? So I would use elimination. And what I always do to start, and this is what the video does too, is it kind of labels each one of these equations. A, B, C, you can choose whatever you want. I'm just trying to label them because the most important part about doing these is kind of making a plan up front. Okay, I'm going to look here and see what my goal is. I've got to do elimination twice to eliminate the same variable. So then I end up with 2 equations, 2 unknowns. Okay, if I look through here, I think y is going to be the easiest to eliminate because y here has no coefficient. So if I wanted to do something with these 2 equations, all I have to do is multiply this by negative 3. And if I want to do something with these 2 equations, all I have to do is multiply this by 2. Does everybody see that? To eliminate y. So my plan, I'm going to make my plan up front. I'm going to take c and multiply it by negative 3. I'm going to multiply this whole equation by negative 3 and add it to b. Everybody see what this stands for? I'm going to multiply c by 3, negative 3, and I'm going to add it to b. And when I do that, I'm going to eliminate y.
Okay.
Right? Then I'm also going to multiply c by 2 and add it to a. That will also eliminate y. Okay, and if I can eliminate y twice, I'll end up with 2 equations, 2 unknowns. I know how to do that because I've been working on that 2 sections ago. Right? So let me show you how this works. So if I multiply negative 3 times c, I end up with negative 18x plus 3y minus 12z equals positive 3.
And you're going to add that to b
Nope.
plus b.
Yeah, so now I'm going to add that, you're right, add that to b. So that's 2x minus 3y plus 5z equals negative 14.
And now you're
I would encourage you to write every step.
okay.
I write every step.
So we should write every step.
So if I need to do that, don't think that you can just skip steps and you'll get the same answer, because you won't. Write every step, because all the negatives and positives here make a huge difference. And after looking and knowing how you did on the chapter or the section test with 2 equations, 2 unknowns, many of you made mistakes on your positives and negatives. So you're going to carry those same mistakes, 3 equations, 3 unknowns, if you don't write every step and aren't very precise in everything you do. Okay? So I'm going to add these 2 together, and I'm going to get negative 16x. My y's cancel, which is my whole purpose, minus 7z equals negative 11. With me? Okay, so now I have 1 equation with 2 unknowns. I need to have 2 equations with 2 unknowns, so that's what I'm going to do over here. This was my plan up front. I'm going to move this over. Okay, so now I'm going to take 2 times c. Don't forget to multiply it through all the way to the end. Some of you forgot to do that on the quiz. And I'm going to add that to a. And I'm going to get 16x. Y's cancel. Okay, now I've got 2 equations, 2 unknowns.
I'm confused why you chose to multiply them by 2 and 3.
Well, I
Is that
picked
a common variable, or-
I picked one of the variables I wanted to eliminate up front.
Okay.
Okay, and I decided to do y because it doesn't have a coefficient.
Right.
So for me to eliminate y, if I add it to this equation, I'm going to have to multiply it by negative 3.
Oh, okay.
And for me to eliminate y, to add it to this equation, I'm going to have to multiply it by 2.
Okay, that makes sense.
Does that make sense? Good question. Okay, now I have 2 equations, 2 unknowns. 7, let's make that a 7, equals negative 11, and 16x plus 11z equals negative 1. Okay, so now I'm back to where I was 2 sections ago, where I was given 2 equations, 2 unknowns.
3.4.
Yes. Okay, if I add these together, I don't even have to multiply by anything, right? It's already set up for me. So this becomes 4z equals negative 12. So now I know z is equal to negative 3. Now I can go back into either one of these equations and plug it in. So negative 16x minus 7 times negative 3 equals negative 11. Negative 16x plus 21 equals negative 11. Subtract 21. Negative 16x equals negative 32. So x equals 2. Now I know x and I know z, so I can go back up to my original. X is 2. Z is negative 3. So I can just plug those in. 4 times 2 is 8, plus 2y. 3 times negative 3 is 9. So I have 2y minus 1 equals 1. 2y equals 2, y equals 1. So my answer then, x is 2, y is 1, z is negative 3. That's the point where these three lines intersect. Three planes, really, is what they are. Okay? These take a lot of work. They're not hard, but they're very easy to mess up when you don't do things precisely. If you don't write your steps down, if you don't plan ahead, if you don't make sure when you distribute in a negative that you're turning your signs negative. All those little things that we learned in pre-algebra and elementary math, you've got to do them correct for these problems to come out. Now, how could I decide whether 2, 1, and negative 3 are the right answer? Plug it into the other two equations. Okay, if you don't plug it in and you just report that answer, it may be right, it may not. You may have had an error as you went through the process. I think in web work for this section I only assigned 5 problems because they do take some time.
Also in web work on the very first question, it says your answer is x equals y equals y equals. Which one is z? So I have 3 different variables.
I need to get 3.5 done first.
It's probably a typo. The last
that
one
was
should just be z.
Okay.
Okay, I heard a couple of you had some questions on 3.5.
Yeah.
So why don't you give me one of the problems that you're having?
One second, let me go back. Let's start with number 1.
Okay.
Okay, so it says, given the system of inequalities below, determine the shape of the feasible region and find the vertices of the feasible region.
Okay.
Or so on and so forth. Your first equation is x plus y is less than or equal to 5. 2x plus y is greater than or equal to 9. X is greater than or equal to 0. And y is also greater than or equal to 2.
Okay. So the first thing I do is I go ahead and draw the lines that these represent, decide whether they're all going to be solid, right?
Okay.
Right?
Yeah.
X plus y is less than or equal to 5. Well, this means the slope is negative 1, and the y-intercept is 5. Or I could just plug in 0, y is 5, 0, x is 5, right? So my y and x intercepts.
That's your first one?
That's my first one. Next line, let's shade at the end. Next line, 2x plus y is greater than or equal to 9. So when x is 0, y is 9. 5, 6, 7, 8, 9. When y is 0, x is 4.5. 1, 2, 3, 4, 4.5. Now I connect those two. I can do it. With me still?
Oh, 4.5.
I just found the x and y intercepts because it's in standard form. Now x is greater than or equal to 0, so that's this. It's a vertical line. And y is greater than or equal to 0. Well, y equals 0 is a vertical line or horizontal line, right? So now I've got all my lines drawn. Now I'm going to shade. So I can use 0, 0. Is 0 less than 5? Yes. So that was this one. Everybody see that? Is 0 greater than 9? No. So it's got to be on this side. Let's shade this one with green. Right? And then I want greater than 0 for x, so it's this side, and greater than 0 for y. It's this side. So it looks like there's my shape where it overlaps. Mm-hmm. Uh-huh.
How did you graph it again?
I used the intercepts. I covered up the x and solved for y. So y is 9. Cover up the y and solve for x. X is 4.5. Everybody follow that? I'm just looking where the shading overlaps. Okay. Now it wants to know the vertices. Well, the vertices happen here, here, and here. I know that point is 0, 4.5. Sorry, 4.50. It would help if I would x. That point's 4.50. This point was 5, 0. And how do I figure out this point?
Distance rule?
No?
No.
It happens where those two lines are equal. So I just set the two lines equal to each other. Actually, yeah. So I'm going to have, it happens, jeez. It's the point of intersection. It's the solution to that system, two equations. So I could just multiply this by negative. So I know x is 2.
No.
X is
X is 4.
4. Why?
Because 2x minus x equals 1x.
Oh, this isn't. 2x minus x is x. Thank you. Yeah, so x is 4. Now I'm going to plug that back into either one of these. So I have 4 plus y equals 5. So y equals 1. So this point is 4, 1.
Okay.
I just used two equations, two unknowns. Because this is the solution to that system of two lines, right?
Right.
We learned that in 4, 2, and 3, 3, 2, and 3, whatever chapter we're on.
So now we need to find the fourth vertex.
There isn't. It's a triangle.
Okay. It says the feasible region is a triangle. The first is 4.50. The second is 50. The third is 4.1. The fourth is.
You don't have to put something if it's a triangle.
Okay, you just put 9.
But it won't let us grade it.
Says one of them's wrong.
One of them is not correct.
Go back up. Let me see. Go down. Let me see. Oh, wait. Go back up. I want to read the problem.
I don't know.
I want to read the problem.
Oh.
Shape of the feasible region and find the vertices of the feasible region. Report your vertices starting with the one which has the smallest x value. Is that what you did?
Mm-hmm.
The smallest x value is 4.5?
No, it's 4.
Nope.
Me either.
That's right. And then 50. Now try it.
I don't know where I get 0, 0. I don't know what's blank here.
Good. Proceed clockwise. Proceed clockwise from the first vertex.
I got 22%.
So clockwise, if we start with 4.50, the next point should be 4.1. No.
We're starting with 4.1.
We're starting with 4.1. So then we should go 4.50, then 5, clockwise. Is that what you did?
Well, no. That's not clockwise, it's your other way. There you go.
Yeah, so it should be 50, then 4.50.
Did you get sleep last night?
No. Now what does it say? They're all
the answers
correct.
are correct.
Mhm.
Weird.
How did you grab that for?
I love it. But
The fourth one?
Fourth vertex?
You don't have to put anything in. Just make sure you start with your smallest x value. That's smaller than that, so that needs to go up there. Let's go through the textbook check now.
You're not going to do a quiz over 3.5 to 3.7 or 6?
Nope, we're just going to take a test. Okay, so in the diagram below, this one has one unique solution. You can see it's right there at that point.
Yep.
Question 2, when solving a system of 3 variables, if the final step yields this, what does it tell you? There are no solutions. Usually the easiest way to solve 3 equations with 3 unknowns is substitution. False. Elimination. Sal Khan was the presenter. False. And the comment I add is take a minute at the beginning of the problem to determine the best method. Okay. That is it.